Okay, example 5, f of x equals 1 over the square root of x cubed plus 5. The main idea of this is, again, getting to a decent structure before you differentiate. Using a little bit of algebra before we get to calculus. That last problem was ready to go immediately. This one has a radical on it to begin with, so the first thing I would do is still doing algebra, so I'm continuing to call it f of x. 1 over x cubed plus 5 to the half power. Anytime I see a radical, I want to change it to a fractional power correctly. This is a square root, which has an index of 2. X cubed plus 5, the entire expression is to the first power, so 1 over 2. Don't fall into the trap of seeing a cube and thinking it's 3 halves, but x cubed plus 5, the entire expression is to the first power, divided by the index of 2, so 1 half. At this point, if I wanted to differentiate, I have to use a quotient rule, right? Because it's a quotient structure. But I do know about basic algebra that if I have something on the bottom to the half power, to move to the top as a negative half power, right? So f of x, it's still doing algebra here, so I'm still calling it f of x, is going to be x cubed plus 5 to the negative half power. And as long as you're doing algebra, continue to call it f of x. Continue to bring that f of x down. Make sure your paper is labeled appropriately. Okay. Once you get to a workable structure, something easy, something to a power. So I'm going to use the power rule of differentiation. I'm now applying a calculus rule, so I'm doing calculus. I'm going to do f prime of x. The power goes times the coefficient. The coefficient's officially 1, so negative 1 half times 1 is negative a half. I take my something, which is x cubed plus 5, and raise it to one lesser power. Negative 1 half minus 1 is negative 3 halves. Then I have to take the derivative of the something, which is 3x squared. Again, that's the derivative. That's a fine answer right there. You can leave it like that. If you wanted to beautify it up a little bit, the last thing I would do, again, this is a little bit of algebra going on here, so I'm not changing what f is. F prime is still f prime. Negative 1 and 3x squared are both on top, so negative 3x squared. On the bottom we have 2 times x cubed plus 5 to the 3 halves power. You can leave it like that if you wish. That's a fine answer. I would probably leave it there. Personally, if you really wanted to go back to radical form, it would look like this. F prime of x equals negative 3x squared on top. 2 times the square root of x cubed plus 5 cubed. Going back to radical form, since it's the third power and the second root, we take the square root, we take the binomial to the third power.
Either one is good.
I'd probably stop here personally, but again, if some people really like radicals more than half the fractional powers, that's how you go back to the radical form. I would take either one of those circle ones as the correct answer for that. I probably personally stop here. I'm a big fan of stopping when I have a correct answer that I don't have to do extra stop to.
So I'll probably mess up on the
Yeah, I mean, yeah, if I went from here to here and messed up, I'd feel bad. So anyway, that's how to handle that. Again, pay close attention to structure. Replace the, if it's an of something that isn't x, replace that with the word something, and then whatever type of function you're dealing with. Cosine of something, it's a cosine function. Something to a power, it's a power function. All right, that kind of thing. So really focus on the type of function it is to establish what type of differentiation is necessary to do it.